Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. Today I'm going to look at a way that you can make light work of a heavy load as I explore pulleys. Let's check it out. It used to be that humans had to rely on muscle power to lift and move heavy objects. However, with the invention of machines like pulleys and levers, this became much easier. Today I'm going to use some simple items to make a pulley and explore the power transfer that's involved in lifting heavier objects. For this activity, you will need an empty box, some sharp pencils, a pair of scissors, a couple of paper clips, some string and some hexagonal nuts or washers to use as a weight. The first thing I'm going to do is stand the box up, and near the top I'm going to stab a pencil in until it is supported by the box. Then I'm going to cut a piece of string which is slightly taller than the box is, and I'm going to tie a paper clip onto each end of the string. I'm going to bend out a small part of each paper clip, and this is to be used as a hook for me to attach my weights onto, and then I'm going to drape the string over the pencil on the box. This is a simple pulley that I've made, and now it is time to test it. To do this, I'm going to put two nuts onto one of the paper clips using that simple hook that I made, and then when I let it go, you'll notice these drop down to the table and the other paper clip is lifted up into the air. I'm now going to put nuts onto the empty paper clip, and I'm going to see how many nuts I need to add to that to be able to lift the first two up off the table. In an ideal world with a simple pulley, the effort to lift the weight would be equal to what the weight is. So in this case, we were trying to lift two nuts, and in an ideal world, you would be able to do that with two nuts on the other side. However, what is happening though is the nuts being added onto the second side also need to overcome the friction between the string and the pencil, and that is why a bit more effort is required to lift the first two nuts that were put on. Now, most simple pulleys actually involve some form of wheel that moves with the rope or string, and that makes it easier to get a balance between the effort being put in and the weight being lifted. Now that we've tested that, we're going to adjust this pulley slightly to make it into a compound pulley and see if that is any more balanced at lifting the weights. To make a compound pulley, what I'm going to do is stab another pencil into the box so it is in line with the first one and there's a gap in between. Then I'm going to cut a piece of string that is roughly twice as long as the box is tall. Then I'm going to tie one end of the string onto one of the pencils, and I'm going to slide a paper clip along the string so it sits in between the two pencils, and I'm going to tie a paper clip onto the other end of the piece of string. To the paper clip that is dangling in between the two pencils, I'm again going to add two nuts. This will drop the string down and you'll see that the empty paper clip is lifted up into the air. Now what I've got set up is called a compound pulley. There are two parts to it and the string is twice as long. You might notice that I've had to slightly adjust a bit of string that I've tied on here from where you saw it in the setup, and that's because the two nuts that were on the paper clip weren't touching the table. So I just adjusted this bit of string slightly, and now those two nuts are sitting on the table. However, now that adjustment is made, it's time to start putting nuts onto the empty paper clip and see how many of those it takes to lift the first two nuts up off the table. This time you'll notice it only took two nuts being added onto the empty paper clip to be able to lift the original two nuts up off the table. That is half the number of nuts required to lift the weight in this activity than with the simple pulley. So we've seen there that a compound pulley is more efficient at lifting weights. However, although it takes less effort, that effort has to travel over twice the distance because the string with the compound pulley was twice as long as it was in a simple pulley. The more parts you add to a compound pulley, the longer the string will need to be, but the less effort you will need to put in order to lift equivalent weights. So compound pulleys are more efficient than simple pulleys. Remember to extend this activity by using empty thread spools if you have them to try and make your pulley even more efficient. Well, that's all for this week. I hope you enjoyed it. If you did, please hit the like and subscribe buttons to stay up to date on all future content. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demos I've done so far, here to my STEM career interviews, and here to my Things You Should Know videos. This has been STEM with Mr. N, exploring pulleys.